grouping like by, well, you're selecting by dates of deployment, airline, flight, and their fare, and then you're grouping them by their dates, and on the dates you bring their airline, their flight.
Sure, what do you mean by you're grouping them by? What does that mean?
You put them in like the same,
Same row.
Row, yes, in a row.
Yeah, because I've got multiple people searching for flights, and some of you are probably gathering data on the same flights without realizing it. And what this does is it says if on, or maybe Luke is logging in like every hour and collecting some airfares and putting them down. And what I'm trying to do is, no matter how many airfares I have for a given date for flight number from airline, departure airline, no matter how many of those row values I have, I just want to compress them all into one row value for a given date for Delta 4321, for example. And then all of Delta 4321's collected fares for that day get averaged together, and that's all in one row. That's what group by does, is it takes all rows with similar values for the field names on the group by clause, date, departure airline, and departure flight number, and makes them into one row by combining the values that are not in the group by, that are in the select clause but not in the group by clause, by using that aggregate function there, which in this case is average. Does that make sense? So that's one thing that I introduced in class last time, is there exists this group by thing that groups stuff together, and that's how we typically use aggregate functions. I guess that's why I talked about aggregate functions just before talking about group by functions. And then right after talking about group by, I feel like I introduced another bit of SQL into the situation. What is this clause doing that's different from the previous clause?
You're averaging fares for that day.
Yeah, I was doing that for the previous clause too. I am rounding those averages to 2 decimal points. That's different. But I'm talking about something else, something that's, more colorful. Yeah.
You're putting them into fares daily.
What is fares daily?
That's, are you just creating it?
Yeah. Generally, into is creating a whole new table. And would it overwrite fares daily if it already existed? I bet it would. I bet it would replace any previous fares daily with this new table that's being returned, and we're just giving it the name fares daily and essentially creating a whole new table out of bits and pieces of previous tables. In fact, in this case, we're only taking bits and pieces of a single table, fares 15, but we could do fares 15, interjoin this, interjoin that, join a whole bunch of tables together, and just grab a couple of columns from each and build a hybrid table out of whatever is being returned by that select clause. And in this case, we're also using the group clause to say whichever rows come back with the same exact values for DT, that airline, and that flight number, they're all going to be combined into one row, and their fare is going to be combined into an average, which will be rounded to 2 decimal places. I guess if I'm talking about airfares, it doesn't make sense to pay attention to values beyond the 2nd decimal place, because I'm probably paying for these things in dollars, and so, I mean, the smallest I'll ever need to go for an airfare is pennies, so I'm just going to round off anything beyond the pennies. That makes sense? And so, if fares 15 is the database or the table containing the data of airfares that I've been collecting all semester long, And it looks something like this. A whole bunch of,
Aren't you on a military time, or it doesn't matter?
I do prefer military time, but I didn't set these to display in military time. So they just have AM and PM. It makes them a couple of characters longer. It annoys me eventually, but this is an example database that I never really change. So in my own databases, they tend to be military just to be shorter. What was I talking about? Yeah, this is more or less the same query that I was talking about before. If I apply this query here to that FAIRS 15 table, Luke, you were telling me that this would give me a single row for all return values that had the same date, departure, airline departure, flight number, and however many rows there were, we'd take all of their fares and average them together into that last column, which is unnamed, but I suppose I could name it. Maybe I'll name it AVG fare just to give it a reasonably descriptive name. What is the keyword I use to rename things? As, and then AVG fare, for example. And so, is anyone surprised to see this? Again, this is the query from the top. I'm not actually creating a new table here, but what I'm seeing is 4 rows for 827 because apparently I was only tracking 4 flights. 4 rows for 828, 4 rows for 829, 4 rows for 830. Even though I believe the data that was in that original FAIRS 15, there were multiple fares collected in the course of a single day. It's just that for flight 5773 that was collected at 7:08 p.m. and 7:25 p.m. and 7:42 p.m. and 7:59 p.m., all of those rows were consolidated into a single row, were grouped into a single row, and all of the fares associated with those consolidated rows were averaged together. And I mean, I think they were, well, no, they were always 340 in that same hour period. And so maybe I'm not changing much, but maybe if the fare was different in the morning and changed in the afternoon, and then these are the evening fares, then the average value won't necessarily be the same as what we're seeing here. We're only seeing the first 13 rows of 1,500 rows, and so there's room for these values to change. There's a reason to actually aggregate by calling average. All right, so I just want to make sure that you guys know how that group by thing works, and group by is always used when we're using an aggregate function somewhere. And I'm going to convert this into a select into clause by adding to the end of the select clause the into keyword, and then I'm just going to give this thing another name. Fares daily is, I believe, what I had called it in that. And so basically everything that you saw displayed in the result set from this query is now just going to be saved into a new table called fares daily when I execute this. And I believe Access always throws up a dialog box to confirm, hey, you're about to create a new table, are you sure you want to do that? There it is, you're about to paste 60 rows into a new table. So 1,500 rows are being changed into 60 rows because we're averaging all similar rows by date and flight number, essentially. And so now I just saw Fares Daily pop up here, and I can see that the contents of the Fares Daily table is exactly the same as the contents that I had gotten when I had run this query here. In fact, when I am trying to figure out what query I want to type into my code when I'm writing a program that's making queries the database, I often test them out in Access in the query window to make sure I'm getting what I want before I actually create a physical table with that value in there. But okay. So now I've created myself a fares daily table. I have the daily average fares for these 4 flights that I've been tracking for like forever at this point. Could we possibly have more fun than this? Let's try. Shifting gears just a little bit here. Well, now I'm just going to start grabbing stuff out of the fares daily table, which I'll remind you contains the columns date and departure airline and departure flight number and fare, probably called average fare at this point, but I think this table only has 4 columns in it. So I am grabbing, I guess it must be named fare. Oh, you know what, I bet this isn't going to work because I changed my SQL query on the fly. I thought I was being so smart, so forward thinking. I'm going to reselect into fares daily so that my next examples work. Where am I? I need to go to query design and run. The existing table fares daily will be deleted before you run the query. Yes, I want to continue. Yes, because fares daily is already open somewhere. Close. Yes, sure. And run. Pasting 60 rows into a new table, and now I'll open up fares daily just to make sure that it's not named fare. Okay. Since my next example is going to want to grab fare out of fares daily, I'm going to make sure that my query correctly creates this table that I'm going to be using. Average fare as fare. It's not open in another tab. I can run it. It will be deleted. I'm not going to rename it. I'll let Access rename it, and then I'm just going to change it in the final table. Run, delete it, paste 60 new rows into it. Thank you. All right, fares daily. I don't like that it's named expression 1003. I'm going to go into the design view and change this field name to fare, because I think that makes sense. Save it, otherwise it's going to ask me to save it anyway. View, my change has been saved. That's great. I still forgot to put that average and around to 2 decimal places, but I guess I'll live with that. Okay, so now I have a new table called fares daily, containing 4 rows, and they are daily fares of these 4 airlines, daily average fares of these 4 airlines. Why is there a down arrow in that column? I don't think I clicked anything special. Okay. Maybe it makes no difference. Oh, that was just my cursor. Okay. So that's fine. A new table called fares daily. At least now it has a field named fare, so that my next SQL example will work. What's my next SQL example? Here it is right here. Oh, God. Mr. Kapitsky, will this SQL query work finally? Do I have a field name called DT for date? Do I have a field name called fare for fare? All right, I'm not breaking any rules so far. Do I have a table named fares daily? Yeah, thank God. Where, is there a departure flight number field in Fares Daily that I can use to filter the results by? Yeah, I think those are those are 3 of the 4 columns. Date, departure flight number, departure airline, and fare. So I'm using 3 of the 4, and it looks like they're all spelled correctly, and I'm assuming that I have a Delta Flight 4123 in that list. Assuming all of this is true and correct, and I believe it is at this point, finally, Mr. Kapusky, what is this going to return?
Just the date and the average fare from flight number 4123.
Yeah. Oh, I guess before I've talked about the order by clause, which just sorts things in a particular order. What do you suppose you could do with data that looks like this, Mr. Kapusky? And I'm just going to add that order by clause just to make sure that everything is sorted by date. That probably makes the most sense, right? Well, I guess it depends on what I'm trying to do. What do you suppose I'm trying to do, Mr. Kapusky? Run that or hit view, either way would give me basically the same thing.
Just find the average price for each day.
For that one flight.
flight.
Yeah. So out of the 60 rows that were pasted into the Fares Daily table, now I'm just showing the 15 rows for this one flight number, which, I mean, if I really wanted this to be comprehensible, I probably should have printed the value of airline and flight number, so we would know that we were talking about Delta Flight 4123. But this is the ordered daily fares for tickets bought on Flight 4123. Delta Flight 4123. And if you were in a Professor Neville class, and this was data that I wanted you to display in your report, how do you suppose you would be displaying that data? What is Professor Neville's favorite way of viewing numeric data?
Probably the scatter plot.
Probably a freaking graph, you know? This is a perfect setup for basically tracking the price of Delta Flight 4123 on a daily basis from one day to the next. And apparently I don't care about how many times it changed during each particular day. I don't want to see 15 dots for a single day. I just want to see one average dot for every day and get a general sense for how has this price been changing over the last, 15 days or so. I guess it's over 30 days. It's just some days I didn't take readings, apparently. 8:27 to 9:2, I missed 9:3, I missed 9:5, 6, and 7, and then I took a whole week off, apparently. And then fell asleep between 9:18 and 9:25. But okay, this is the data that I have for about a month's worth of collection. And I mean, to be honest, this is probably what a lot of student data looks like, and this is why I have everybody throw their data together so that any holes created by one student might be filled in by another student tracking the same flight. So our time series, our graphs can look as full as possible. But yeah, so maybe this is what I'm after. This is the sort of thing that I'm after. This is a query that returns average values of all of Delta Flight 4123's daily fares. Would that be a fairly complete description of what I'm extracting from my data set here? All right, well, this slide promised more fun. Who's having more fun? I don't see any hands up yet. I better go to the next query then. More fun. It's a promise. So we know what this does. Mr. Late, Can you tell me what this does? The day I figured out how to do this, I blew my own mind.
I guess, well, if I read the title, it says it's making a 2-day time series.
Yeah, sure. So what do all of these letters mean?
Well, I guess A is one table and B would be, well, a second table.
Yeah. What are those tables' names?
A and B, well, according,
Sure, and what are those tables' sources?
let's see, one is, would they both be?
They're both the same table. And so we're actually making a second copy of Ferris Daily. The first one we're calling A, the second one we're calling B, and what are we doing to them?
You're doing an inner join.
We're joining them on the basis of what?
Where,
Yeah, it's actually not in the where clause anymore. Inner join likes to have the on, and so the where clause is actually in the from
It's-
clause.
where the date of B is equal to the date of A minus 1. So it'd be the previous day?
Yeah, because dates in Microsoft products and computers in general, if we're not talking about times, just the date, that's going to be a floating point number, but it's going to be a floating point number with a 0 after the decimal. The time is what makes the decimal value change, and so noon on a day is 0.5. I guess 6 p.m. on a day, 18 hours into 24 hours, is going to be 0.75. But if we're not worrying about time at all, we're just assuming like midnight on the day, so 0.0 after that floating point number. And yeah, so we're basically saying whatever the date value is in table A, we're going to subtract 1 from that, and then match that to that date value in table B if it exists. If it doesn't exist, then that row, then I'm not going to print that row. And I'm only going to print combined rows where I can do this matching here. And I'm grabbing all of this out of the Ferris Daily table, which contains 4 different flights. And I don't really want to join my flight number data from 4123 to something that's not 4123. And so I'm making sure that all joined rows in A and B are also for flight number 4123, as well as for having the date off by 1 hour. What is a time series?
Subtracting values like over time and seeing if they increase or decrease or stay the same?
Yeah. So the fare for the flight on this day, and then the previous day or the next day. It looks like I'm doing the date minus 1 date first. So this is the previous day, and then today, the previous fare, and today's fare. So I'm expecting to get out of this query result a temporary table. I'm not saving it into a new table, but where each row has flight number, and then 2 dates, 2 consecutive dates, and then 2 fares where the fares are from those consecutive dates. Does that make sense? According to the A's and B's, we're basically saying, we're basically applying variables to these tables. And we do this even when the table names are different, but it's especially useful when we're actually trying to join the same table to itself, but offset by a certain amount, so that we can create something like a 2-day time series. So just so I don't waste too much time by mistyping things, I'm just going to copy paste this back into Access and make sure that works. All right. Oh my goodness. Explain this to me, Mr. Lake. What am I looking at here?
Well, you're looking at the first column is the flight number, and then
I'm finally providing you with some context. Yes, we're talking about this flight number. Okay.
and then it's showing the B dot, the dates for the table is the first day,
Yeah, we're confirming that we're seeing previous day and then next day.
and then the A date is the very next day.
Yep.
And then it's just showing each of the fairs for first, the fair for the first day, and then the fair for the second day.
Yeah, so this table result tells me that flight 4123 between 827 and 828, the fare didn't change at all, but then from 828 to 829, the fare went down by a little bit, and then it went down by a tiny little bit more from 829 to 830, and it went up from 830 to 831, and then it stayed at 405 for, you know, whatever 2-day periods that I'm tracking. I mean, I did miss some days here, and so some days weren't able to match the previous days, and so the next time I found 2 rows that could match together, we were in the middle of September, and apparently I missed too many days in the 925 area where there was never a previous day that could be matched for these flights. And so typically, what you see when you interjoin any tables at all is not every row is going to match with every row, and so often the number of your data rows tends to decrease with the additional tables that you join into that query, because every new table represents an additional constraint full of rows that may or may not match. And so generally, it's hard to keep the same number of rows as you add more tables. Generally, the number of your rows will decrease as more constraints are applied. Why do you suppose I'm doing this, Mr. Kapiski? Why am I trying to do a 2-day series? Hold that thought. It is so freaking cool. But you know what is even cooler than a 2-day series where 2 copies of Fairs Daily is multiplied is joined to itself? Well, 30 days would be awesome. But I don't even think I have 30 days worth of consecutive data in that table. But I bet I can do like 3 days, right? Or 5 days, maybe that I can manage. How, now that you've seen the code that creates this, could you create me some code that gives me 5 consecutive days of fares so I can see how fares vary over 5 days on average? Yeah. You could at least be able to recognize and interpret what such a query was doing, I'm hoping. So, let me fulfill the promise of yet more fun, because here it comes. Oh my goodness, Mr. Kapiski! Tyler! What the heck is this?
That doesn't look fun.
So much more fun. It's like I've squared the amount of fun that we were having in 2-day time series, which itself was squaring the amount of fun we were having in that first SQL query. This is like, what's beyond a cubic? That amount of fun, whatever that is, quad-dick.
They just say to the floor. There is an capacity of it.
Fun to the 4th, that is correct. What is happening here?
You're doing the same thing, but you have a lot of and statements.
And I have a lot of parentheses. I want you to notice the parentheses, because the parentheses are going to ruin your life. This statement right here is joining table A and B. You find that table, that statement right here, joining table A and B. Exactly the same text, exactly the same way. And then, this is a joined table. You saw a copy of that up here. That table is being joined I'm actually doing this a little bit differently than here, because I'm also saying b.date is equal to a date minus 1, and a flight number is equal to b flight number. And I'm only mentioning the flight number is 4123 down in the where clause. I suppose I could have added that in as an and up here, but that would have made things kind of long. But anyway, okay, so I have slightly changed this thing, but this statement is basically doing the same thing that this entire statement is doing right here. And b dot date is equal to a date minus 1. Okay, I guess it goes all the way out to here. Okay. Inner join to this table another copy of Fair's Daily named C, where I know that I've got an A dot departure flight number in this table, so I'm going to match that flight number here to C dot departure flight number. So only rows that have the same flight number, and where in the C table the date value is 2 units, two integers lower than A dot date. That is 2 days previous. So I have A dot date, which is the most current date we have. B dot date is the day before. C dot date is 2 days before. And D dot date, which is A dot date minus 3, that's going to be 4 days before. That's why I'm calling this a 4-day time series, because I'm not even showing you all the dates anymore, but if I did have A dot date, B dot date, C dot date, D dot date, they would be, I would probably print them out in order D dot date, C dot date, B dot date, A dot date, so that they would appear in increasing order. But I'm showing you the most recent date that I have the fares for in that 4-day time series. I'm showing you the flight number for that flight that I'm giving 4 days worth of fares here. I'm showing you the 4 days in a date ordered order. So 4 days ago, 3 days ago, 2 days ago, 1 day ago, and the most recent date. And I'm giving you the date of the most recent date. I'm pulling date out of the A dot table. I'm just renaming it ADT because I don't like dots, I guess. Yeah.
So then how would it display like the very first date that you tracked? Because there's not data for the day for that.
What do you mean the very first date that I tracked? No. In this result, I also don't have the very first date that I tracked because it didn't have a previous day, and so that was lost. That's why result sizes tend to get smaller. And so here, I'm not going to get any rows until I actually have 4 days of consecutive data that I can join together, and then I'll get this first row of result. So, let me copy.
What if like the
Yes.
best price was on the day that got thrown out?
Yeah, that may be, but at the time that I'm running this query, I'm already 3 days beyond, whatever results that I'm seeing. And so even if there was a good price 3 days earlier, that's gone. And so that's not what this is for necessarily. I'm not trying to tell myself, dang it, this is when I should have bought my airplane ticket. I'm trying to tell myself, in which direction are these prices going, and should I wait on buying an airplane ticket, or should I buy right now? Is probably the plan in my head as I am building my way piece by piece from simple queries to more complicated queries to a big complicated query that maybe is telling me something useful about the world that I live in, about the prices that I'm interested in and that I'm collecting here. So let me just escape out of this and copy paste that so I don't have to type it all in with my slow little fingers. I'm going to come back here. I'm going to notice that I have 10 rows that got returned from that 2-day series of data, right? And so now I'm going to go to the SQL view and replace it with this nonsense. And that's going to give me 4 days worth of joined data, of which I'm only showing the fares over the 4 days, and then the last day date, and the flight number. And I'm probably going to get less than 10 rows, because I'm only going to get a row of data where I had 10 consecutive, where I had 4 consecutive average daily fares And you know, I took some vacations during this time and stopped collecting data for some periods, and so it's going to be a little patchy. It's definitely going to be less than 10 rows. This is probably why I rounded those things to 2 decimal points, so I wouldn't have so many columns to fix. But yeah, now I'm down to 6 rows. Went from 10 rows to 6 rows. Because I joined 2 more copies of Fares Daily to this result set so that I could get 4 consecutive daily average fares for flight 4123 here. Okay. Tyler, I'm afraid you are starting to have too much fun. Let me shift gears here. But first, Tyler, can you tell me, what is it that you suppose that I'm trying to do here?
You're trying to find the average, so you can calculate linear regression with it, or at least something along those lines.
Those are pretty much the lines that I'm thinking. Yeah, I just told you guys how to do linear regression, and now I want to come up with a data set that you can apply linear regression to. Sound like fun? More fun than the average CS student can handle. So let me copy-paste the results of that query into, I already showed you my California income linear regression application. So let me show you my linear regression fares application. I've copy-pasted those 6 rows into this table right here. I guess I could probably make things a little bit bigger and visible. We don't really need to see that graph. What could that graph possibly be showing of any interest anyway? All right. And I remember somewhere previously in that linear regression PowerPoint that I had some sort of collection of summation equations which when combined together, the sum of x's, the sum of x squareds, and things like that, I could figure out things like the m, the slope, and b, the y-intercept of a straight line passing through, let's say, these points here. And you know, when I build myself a linear regression data series in SQL, I usually create one more data value than I really need for my model. I don't want to predict the next fare based off of 4 past airfares. I want to predict my next fare based off of 3 past airfares and see if I can nail that last airfare right on the head with my formula. And so my x values for all of these data points are, I'm just going to say A is you know what, I think I reversed the names of my fares here. I went to A fare, B fare, C fare, D fare, which is actually the reverse order, but I think I just renamed the fields. The data is still the same. I didn't reverse the data. And so this will be column 1, or day 1, day 2, day 3, and I'm going to try to use the previous 3 days worth of data to predict day 4. And so one of my summation equations is sum of x coordinates squared. So I'm squaring these guys right now, right down here while I know them. These are all my y values. And so I don't know what my predicted fare is going to be yet, but I believe I probably have all of the functions required for these summations already written in white, so I don't have to make mistakes typing them in. If I double click on this sum of y function, I'm just summing together all of the y's for this line. I've got all of the x squareds for the points on this line. And so this is my sum of y's expression. This is my sum of xy's expression. So x times y, x times y, x times y. I'm only using the first 3 points to try to predict the fourth point. I feel like I might be missing a couple of columns, or some stuff somewhere. Yes, no, I don't know, maybe, maybe not. What is this guy asking for? Oh, well, he's all in white. Let's make those formulas black so we can see them. That must be a formula too. Let's make that black. Okay. Where am I grabbing all of this data from? The red series, purple series, green series. Okay, I guess I'm going to trust myself that I am using the sum of xy and subtracting from that the sum of x's times the sum of the purple series, sum of y's is what that is, and then divided by the count of the points that I'm putting together, so 3. All of that divided by the sum of x squareds minus the sum of x's, sum of x's squared, the squared value of the sum of x's, and all of that divided by the count of the points that I'm putting together in order to figure out the average slope of the line that passes as close as possible to those 3 points that are currently in purple here. So that value is what I'm going to put here. That's going to be the slope of the line that goes through these points as much as possible. And I mean, if this is a day 1, day 2, day 3, that slope is going to be slightly negative, right? It didn't stay flat. It actually started going down. And so I expect to see a slightly negative slope here. And then I don't really have any expectations for the b that would make much sense. But at least I can sort of predict what the slope is going to be just by looking at the original y values, the original data there. And so yeah, kind of a negative slope. And so how can I use this m and this b value to predict what the next value in this series is going to be? I mean, these are the coefficients I need for the equation y equals m times day number plus b gives you the fare for a particular day. So b actually is sort of like a starting fare, and it's going to be modified by whatever m times b is. And so one step away from 406.053 should give us something like 405. 2 steps away from 406 is probably going to give us something close to this fare. 3 steps away from 406, going down by something like 0.79 times x. So I guess our price is just going down by like 79 cents per day on average is what that slope means. But so these are the coefficients that I put in for x, 1, 2, and 3 here, to make the y equals mx plus b work, and the y value is going to be the prediction of my model for those fares there. And so if I want to predict the fare for day 4, I'm just going to put in 4 into that y equals mx plus b equation, right? So hopefully that is what I tried to implement in this Excel file in white in this column, predicted fare. Let's make sure that's black so something pops up. And I'm going to double click on that to make sure I'm using m times 4 plus b, and that gives me this y here, right? And so 402.893 is what my model predicts for this value here. I'm not always going to hit this value on the head, but hopefully, if my prices really do change in a linear manner, probably also an assumption that is not 100% correct, but I like starting with the easy assumptions first. They make the math easy. I mean, it's not terribly far. And now that I've got all of these equations set up, I can just propagate them down, drag them down, and not only predict this guy, but come up with a whole new M and B for these three points, and then predict that guy, and a whole new M and B for these 3 points, and predict that guy, and see how well I do. How can I numerically gauge accuracy? So 402.89 is my prediction for this guy based off of the 3 previous days. 402.26 for this guy. 405.50, oh, that's pretty good. 406.107, okay, a little bit further away. 405, actually that day there was a big price drop, and so I'm not surprised that my linear model didn't get very close to it, but you know, on it. The previous few days were okay. And now when we incorporate that price drop in our trying to figure out the M and B for the next prediction, okay. It at least gave us, it tried to give us a slope that made sense, a slope that is going downwards because it started out at 405 for a while and went down to below 400. It's interesting that these fares didn't change at all for 3 days, but our model caught that. It made the slope 0. It said if the price didn't change for the previous 3 days, it's probably going to continue to not change. That is the assumption of using a linear model. Whatever has been happening in the past will continue to happen, at least for a few days for a little while into the future. And so it guessed that the fare on day 4 would be 405. Would be 405 because it didn't change in the previous days there. So, I mean, I think these predictions make sense. It's figuring out the best slope it can and the best B it can for the data that we're giving it. And then it's making the best prediction that it can. I mean, prices probably do not change linearly, but it's a good place to start if we're going to start trying to make predictions. It's at least relatively easy. And how can I figure out the error in my between my actual my predictions and the actual data? Well, there's this thing called sum of squared error, and so I'm going to start getting the differences between my prediction and the actual value, and I'm going to square them so I can sum them all together. And then once I have a sum of all that squared error, I'm going to take the average of that squared error. That's called mean square error. And once I have mean square error, I'm going to divide that by the number of error points that I have. I'm going to take the square root of mean square error. Never mind the average business there. The square root of that mean square error, that's called root mean square error, and that tends to be a standard error measurement in whatever domain you're using numbers in the sciences. And so that's why I built this all up. And so if I finally compute all of my squared errors and get the average of my squared errors, and then get the square root of the average of my squared errors. What this is telling me is the accuracy of my model for, these 6 days that I tested it on is about plus or minus $5 on average for my predictions, which it could be good, it could be bad. I don't know until I can compare against Mr. Kapiski's model. And then I know if I built a better model than him, or if, once again, he just crushed my model and my dreams into the ground. But that's the point of figuring out the accuracy of your models, is to see if the next model that you build, or if the model that you're comparing to, if your model is an improvement on that or not. And so RMSE tells you, did the additional work that you put into this thing actually bear fruit by making the root mean square error just a tiny little bit smaller? And this value is always going to be a positive value. You know that when you take square roots of things, you get the same value, positive and negative, but we're not going to keep the negative value. We're always going to express the positive value. And, you know, since I was creating a table of actual fares and predicted fares, I couldn't resist doing a graph here, which updated as values got placed in that prediction column. And so hopefully I've got a key that tells me what red lines and blue lines mean. So the actual data is the blue data. You can see how the actual data evolved. And then you can see the linear model just sort of trying to fix itself with what's happening in the model, like a big price increase here. So at first, the model thought that things were going to go down, but things went up instead. And so it incorporated that price change in its next prediction, and so its next prediction went up. And so it sort of reoriented itself and sort of fixed itself for a while until something else weird happened. Of course, I didn't collect any data between here, so I'm not really surprised if I'm really way off, because apparently what I'm... yeah. I still used the previous 3 days data to get this, but for whatever reason I think the previous 3 days data was really flat, right? And so they gave me an unrealistic number when a big price drop actually occurred. And so now the linear model is trying to reorient itself to that new state of affairs, but apparently the real life reverted to what it was like back here. And so if I were to continue this prediction model one step further, one day further, probably this point would move much closer up to here. So the model kind of tries to keep close to the data, but it's often going to end up being 1 day behind, just because whatever happened on the last day could throw its assumptions out the window, because this value was from the previous 3 days, but the 4th day was this actual value. And so when that happens, the slope that it figured out from its previous 3 days is completely terrible. But that's what happens with predictions. If things are going to change a lot, then there'll be some amount of lag in the data. So the reason I'm talking about this today, you have an assignment due on Monday that hopefully you don't need much explanation on. And everything that I've been talking about for the last 2 days, maybe even 3 days, are going towards homework 5, which is due 1 week from today. And homework 5 is going to be not about tracking your airfare data, because we haven't collected all that data together. There's going to be nothing to group together. And so I'm not going to have you work on airfare data just yet. I want you to work on wind data, that same wind data that I've been having you look at. And what I want you to do is load that wind data into an Access database and build SQL queries to take out, for a 3-day prediction, for example, to come up with 3-day predictions of what the wind will be if for the last 3 20-minute time periods, the wind speed was this, this, and this. What is the next wind speed going to do? And so grab out 4 consecutive U's, 4 consecutive V's, and then do a U prediction, do a V prediction, and try to predict the next value of U and or V. I forget exactly what the instructions are, but I'd be very surprised if I didn't ask you to do separate predictions of U and V. You don't need to use V's to predict U's or U's to predict V's. Just use same to predict same. Does that make sense? So that's mainly what homework 5 is going to be. I'm going to ask you to build like maybe I think I'm asking you to build a 1-point prediction model. Whatever the wind was doing a 1 time period ago, it's going to be doing that now. The assumption is nothing ever changes. Whatever it was doing before, that's what it's going to be doing now. That's usually not an accurate assumption, but it's going to do better than you think. Then I'm going to ask you to do a 3 unit prediction, and a 5 unit prediction, and a 10 unit prediction. So I'm going to ask you to build basically 4 different models. A point model, a 3-point model, a 5-point model, a 10-point model. something like that, and then show me your results. And really what I'm asking for is show me your RMSEs. Which of these work better RMSE-wise? Does adding more data to your model actually help, or does it not? That's what I'm trying to get out of homework 5. And homework 5, one thing I remember about homework 5, I'll talk about homework 5 on Monday, because I'm taking way over time today. But homework 5 has 6 pages of instructions. And I am not surprising Luke at all. The reason for that is in the past, students have told me that my assignments are way too wordy, and my wordiness just confuses them more. And so what I tried to do last time I did this assignment, it was actually just 3 pages of instructions. And I tried to rewrite those pages of instructions in a more compact and understandable way, and I still ended up with 3-ish pages of instructions. You only have to read the first 3 pages. The second 3 pages is just a copy. It's just my previous set of instructions. So if anything doesn't make sense in the first 3 pages, you can look it up in the second 3 pages to see if it's explained better. But that's why it has 6 pages, is I just tried to rewrite it to express things more clearly, to get fewer complaints from my students. I don't know that it worked, but now I have a second batch of students to test that on. All right, any questions? All right, well, thank you very much. Have yourselves a good weekend. I will see you back here on Monday.